than oxygen.
Negative value of nitrogen.
Intermolecular force of attraction depends on the number of electrons. So oxygen has 16 electrons, nitrogen has 14 electrons. Since nitrogen has less number of electrons, the intermolecular force of attraction between nitrogen molecule is weaker than in oxygen molecule. So it distills off fast and gives you pure nitrogen and not oxygen. So it is not the covalent bond state. It is the intermolecular force of attraction. So industry prepares nitrogen by this method. Liquid air means when you liquefy the air, you lower the cooling to low temperature, so the gas changes to a liquid.
So
Air
means
is
since air is a mixture of all means so that every gas is liquefied at that temperature.
yeah, except helium. Helium has the lowest, 4 degree Kelvin, 4 Kelvin. So helium is not. But nitrogen, oxygen, xenon, they will get liquefied. Why nitrogen is chemically inert? Because of its high bond dissociation energy. It has a triple bond. The bond order is 3 in nitrogen molecule. However, lithium, magnesium, calcium, barium, and aluminium, they react with nitrogen on heating, gives lithium nitride, magnesium nitride, calcium nitride, they give ionic nitride. They form ionic nitride. And what is the proof I have that they form ionic nitride? Because ionic nitride on reaction with water gives ammonia. This is a proof that you have ionic nitride. The covalent nitride will not give ammonia on reaction with water. It is only the ionic nitride at room temperature. At room temperature, remember, if you add water at room temperature, it will give ammonia. You don't have to heat it. Calcium carbide, when you react with nitrogen and heat it to 1100 degrees Celsius, you get calcium cyanamide plus carbon. And this is called nitrolim, which is a fertilizer. Calcium cyanamide with 5 moles of water gives you calcium carbonate plus 2 moles of ammonia or ammonium hydroxide. Calcium cyanamide, when you heat it with carbon and sodium carbonate, you get calcium carbonate, a precipitate, and sodium cyanide is soluble in water. So you can add water, sodium cyanide will dissolve it in water, and from water, when you crystallize, you get pure sodium cyanide. Nitrous oxide is called laughing gas because if you inhale the gas, it causes laughter. And that is why it's called laughing gas.
Yes.
Hydroxylamine with nitrous acid will give you nitrous oxide plus water. Nitrous oxide has two resonating structures. It is a new linear molecule. Its shape is linear. How do I know its shape is linear? So what you do is count the valence electron. So N2O, 5 into 2 plus 6, 16. Each nitrogen has 5 valence electrons. Is it?
Yes, sir. Yes.
And oxygen has 6 valence electrons. Because nitrogen is the 15th group, oxygen is the 16th group.
16. Yes.
So total number is 16 divided by 8. The quotient is 2. And 2 is means bond pair, 2 bond pair has to be linear. So it is linear and it has two resonating structures. It's a neutral oxide. Nitrous oxide plus oxygen. Nitrous oxide plus oxygen mixture is used as the anesthetic agent for dental surgery. The reaction of nitrous oxide always gives you the oxides of the other element and nitrogen as the product. So P4 plus nitrous oxide will give me P4O10 plus nitrogen. So 10 moles of nitrous oxide will give me P4O10 plus 10 moles of nitrogen. Magnesium plus nitrous oxide will give me magnesium oxide plus nitrogen. Carbon plus nitrous oxide will give me carbon dioxide plus nitrogen. Sulfur plus nitrous oxide will give me sulfur dioxide plus nitrogen. So you see, always the oxide of the other element is formed and nitrogen is the product of nitrous oxide. Sodamide. Sodamide, when you react with nitrous oxide, you get sodium azide, which I use for preparation of nitrogen. Sodium azide plus water. How do you prepare sodamide? Now sodium, when you heat it in presence of ammonia, it gives you sodamide plus hydrogen. So if I pass ammonia gas over heated sodium, it gives you sodamide plus hydrogen. The sodamide, when you react with nitrous oxide, it gives you sodium azide plus water. Now you see here, copper goes to copper 2 plus, it involves it releases 2 electrons. Nitrate ion goes to nitric oxide. It involves 3 electrons because the nitrate ion, the nitrogen is plus 5. In nitric oxide, the nitrogen is plus 2. So it is a change of 3 electrons. Then the ratio should have been 3:2. But why I have written 8? This involves 2 electron chain, this involves 3 electron chain. Then it should be 3:2. But why I have written 8? Because you have to provide 6 nitrate ions.
Yes.
So you need additional nitric acid to provide an ion to the copper 2 plus. Each copper 2 plus requires 2 nitrate ions. 3 copper 2 plus requires 6 nitrate ions. So you need additional nitric acid. So it gives you 2 nitric oxide, it gives you 3 copper nitrate, and it gives you 4 moles of water. Don't try to remember. Try to analyze why I require 8. Students generally try to memorize 3 and 8. Don't do that. It's a wrong way of learning science. You have to learn logically. So when you react ammonia, burn ammonia in air, in presence of platinum as a catalyst, you get nitric oxide plus water. Okay? Balance the reaction.
4NH3 plus 5O2 is 4NO plus 6H2.
Good. Now NO reacts with oxygen, gets oxidized to nitrogen dioxide, and nitrogen dioxide, when you add water in presence of oxygen, it gives you nitric acid. Why oxygen? Because NO2 plus water will give me HNO2 plus HNO3. And this will be oxidized to HNO3. So in absence of oxygen, you will have a mixture of acids, nitrous acid and nitric acid. And in where oxygen will oxidize nitrous acid to nitric acid. And that is why you require to pass oxygen in water. The last one is brown ring test, where you take nitrate ion plus ferrous ion plus acid. It gives you ferric ion, nitric oxide plus water. Balance the reaction.
Hydrogen minus plus 3 Fe2 plus 4H4.
What?
Yes. 3. Jack. 4H plus. 2H2O.
Twice H2.
Yes, sir.
Okay, now you know how to do it. Fine. I'm happy that you can do it. So, this is the brown ring test which you do for detection of nitrate. The first reaction which it produces is nitric oxide. And this nitric oxide now reacts with only 2 compounds are known which has iron in +1 oxidation state. And one of them is a brown ring. So brown ring has iron in +1 and it has 3 unpaired electrons. How do you get 3 unpaired electrons in iron 1? So transfer the electron from the S to D and you have 3d7 4s0 configuration. What is the proof I have that there will be a transfer of electron from S to D? 3d6 4s1 3d6 4s1 will have 5 unpaired electrons.
Ah.
4 in the D and 1 in the S. But 3d7 will have 3 unpaired electrons.
Yes.
This is one proof. But the second is, what is my basis for transfer of electron, even if I do not know the magnetic moment? Because what is the coordination number?
6.
If it is 6, what is the hybridization? I do not know. I said sp3 d2 or d2 sp3. These are the two options. Both
Yes,
requires
yes.
both requires a vacant s orbital.
Yes.
So if I don't transfer the electron, how can I make it vacant? That is the basis why s electron has to be moved. Like nitrous oxide. Nitric oxide also, the product is nitrogen. P4 plus 10 NO gives P4O10 plus 5 nitrogen. So the nitrogen is the product. 2 copper plus nitric oxide gives you cupric oxide plus nitrogen. 2 NO plus Cl2 gives 2 NOCl. That is called nitrosyl chloride. Permanganate. Fill in the blank and complete the reaction. Now balance. I have 5 negative charge. I have 6 positive charge. So the overall is 1 positive. 3 negative. So you require 4 H plus to become 1 positive. So it will be 2 moles of water. When you use concentrated nitric acid with a metal, you get metal nitrate and always nitrogen dioxide as a product. Remember, concentrated nitric acid will always give you nitrogen dioxide, and which is a brown gas. This to this is a 1 electron change. This to this is a 2 electron change. But I need 2 additional nitrate ion for copper. So how many moles of concentrated nitric acid per mole of copper? Nitric acid to nitrogen dioxide is a 1 electron change. How many moles of nitric acid? This to this is a 1 electron change, this to this is a 2 electron change. So it has to be 1:2. And then 2 additional nitrate ion. So it has to be 4 moles of nitric acid per mole of copper. Can you not see it is a 1 electron change, it's a 2 electron change? So the 1 mole of copper requires 2 moles of nitric acid. An additional 2 moles required for the nitrate ion. Lead nitrate. This is a very special reaction. Heavy metal nitrate gives nitrogen dioxide. Lithium is the lightest metal. It also gives nitrogen dioxide plus oxygen. Potassium nitrate on heating gives potassium nitrite and oxygen. Sodium nitrate on heating gives sodium nitrite and oxygen. No nitrogen dioxide. lithium shows an anomalous behavior. So you have to be extra careful for that any element which shows an anomalous behavior, you have to give a special attention to that. So when you cool, when nitrogen dioxide is cooled to minus 10 degrees Celsius, it becomes colorless, it becomes diamagnetic. And that means, so when it dimerizes, the odd electron gets paired, so it becomes diamagnetic. There is no odd electron to be excited, so it becomes colorless. Nitrogen dioxide gives the product nitric oxide as a product. Iodide to iodine is a 2-electron change, and NO2 to NO is a 2-electron change. So 2 iodide plus NO2 plus water will give me iodine plus NO plus 2 hydroxide ion. Because you have 2 negative charge here, you have 1 water and 1 oxide ion to give you 2 hydroxide ion. So NO2, when it goes to NO plus oxygen, oxide ion, okay, and this oxide ion reacts with water to give you hydroxide ion. Because in nitrogen dioxide, you have 2 oxide ions, and in nitric oxide, you have 1 oxide ion. So another oxide ion reacts with water to give you hydroxide ion. That is why you get 2 hydroxide ion. How do I know that the copper gives cuprous oxide and not cupric oxide? How do you know that copper gives cuprous oxide and not cupric oxide?
Color.
Cuprous oxide is red in color, cupric oxide is black in color. So from the color I can differentiate the product, whether it's the cupric oxide or cuprous oxide. Now why carbon dioxide is evolved? Because nitrous oxide is an acidic oxide. Nitric oxide is a neutral oxide, but nitrogen dioxide is an acidic oxide. So acidic oxide will react with a base carbonate to give you carbon dioxide. And that is why you get sodium nitrite plus carbon dioxide. N2O5 is an anhydride. P4O10 is a strong dehydrating agent. So it takes a molecule of water from 2 moles of nitric acid and converts into N2O5. And the product of phosphorus is metaphosphoric acid. Okay? N2O5 in solid state, it exists as an ionic solid. NO2 plus, NO3 minus. So N2O5 in the solid state is an ionic solid. It gives you NO2 plus and NO3 minus. Only in the gas phase, when it is in the gas, exists as a gas, it exists as a covalent molecule. I2 plus N2O5 gives I2O5 plus nitrogen. Sodium, when you react with N2O5, you get sodium nitrate and nitrogen dioxide. Why it forms sodium nitrate and nitrogen dioxide? Because sodium, what is the oxidation state of sodium here?
Plus. Yes, continue.
N2O5 decomposes slowly to give you nitrogen dioxide plus oxygen. N2O5 is a colorless, deliquescent solid. Deliquescent means which absorbs moisture. So it's a hygroscopic substance. NO2 is a mixed anhydride. NO2 plus water gives you HNO2 plus HNO3. But N2O5 plus water gives you 2 moles of HNO3. An oxide which reacts with water to give you mixture of acids, that is called mixed anhydride. And an oxide which reacts with water to give one type of acid is called anhydride. So N2O5 is an anhydride of nitric acid, whereas NO2 is an anhydride, mixed anhydride. It gives HNO2 plus HNO3. In H, what is the property of mixed anhydride? The property of mixed anhydride is that one of the acid will have an oxidation state lower than the parent oxide, and another will have a higher than the parent oxide. Nitrogen is 4 plus, here nitrogen is 3 plus, and here nitrogen is 5 plus. So mixed anhydride will always give an acid with a lower oxidation state, an acid with a higher oxidation state. Whereas an anhydride will give the same oxidation state. N2O5, when you react with hydrogen peroxide, you get HNO3 plus HNO4. So what is the structure of nitric acid? And what is the structure of peroxonitric acid? Then you have to write 2 resonating structures. Similarly, this will have 2 resonating structures. Because 2 oxygens are identical, you can't differentiate which is forming a coordinate bond, which is forming a double bond. Nitrous acid, you take a barium salt of barium nitride and react with sulfuric acid. Why I choose barium and not sodium or potassium? Because barium reacts with sulfate to give you barium sulfate insoluble, whereas you get nitrous acid in solution. But if you take sodium or potassium, the sodium sulfate is water soluble, nitrous acid is water soluble. So you can't separate them. So that is the reason why I choose barium salt. Because barium can be precipitated as barium sulfate. The metal sulfate which is most insoluble is barium sulfate. It is least reactive. It does not get attacked by acids. Nitrous acid, on heating, changes to nitric acid nitric oxide plus water. What sort of reaction this is?
Disproportionate.
Very good. Now balance the reaction.
3HNO2 plus HNO3 gives 2NO2. Yes.
So N3 plus going to N5 plus and N2 plus.
Yes, sir.
So it's a 2 electron change
2 electron change.
and it is a 1 electron change.
1 electron change.
So what I will have? I have to multiply by 2. So I will get 2 nitric acid oxide. HNO2 3 plus going to NO2 plus 1 electron change. 2 iodide going to iodine releases 2 electrons. So I need 2 moles of HNO2 with 2 moles of potassium iodide to give you iodine plus 2 nitric oxide plus 2 KOH. Is the reaction balanced?
Yes.
Hydrogen is not balanced?
No, sir. 4 and
Okay, then what I have to do is I have to double up this reaction. So if I write this way, 2 iodide ion plus 2 NO2 minus plus H plus gives iodine plus 2 nitric oxide plus OH minus. Will it be all right?
Yes.
No, it will not be all right because in acid hydroxide cannot exist. It has to be water. Can acid, you are working in an acid medium. Can you get hydroxide ion in presence of an acid?
no,
So it has to be water. So how many 4 negative charge? You have 4 moles of H plus gives 2 moles of water. Okay?
Yes.
What was the earlier what was the problem? The problem was I wrote Ki KNO2 plus H plus. It has to be iodine plus it has to be KNO2 will be oxidized to NO.
H instead of H plus.
Now it has if you write HNO2, then where goes the potassium?
It was HNO. In the
So it is better to write in the form of an ionic equation that takes care of nitric oxide plus water. Now H2S plus HNO2.
excuse me, sir.
No, you can do it. Okay, you can do it. You can do it in the full form. Ki plus KNO2 plus HCl. Then I get iodine plus nitric oxide plus KCl plus water. So I get 4 KCl.
2x HNO2.
4x. Nice and straight.
What I did earlier, I have written H plus. I have not given an ion. That is why the problem was there, that K plus was in excess. So when I write in the full form, then there is no problem. So H2S, when you react with nitrous acid oxidizes sulfide to sulfur, and it goes to nitric oxide. So this is a 2 electron change. This is 2 electron change. So 1 mole of H2S requires 2 moles of HNO2 to give you sulfur plus water plus nitric oxide. As a reducing agent, when nitrous acid will act as a reducing agent, when the partner is a stronger oxidizing agent.
Yes.
So if you take permanganate, then you will have manganese 2 plus, NO3 minus plus water. So this to this is a 2 electron change. This to this is a 5 electron change. So 2 moles of this, 5 moles of nitrite R gives me 2 moles of manganese, 5 moles of nitrate R. What is the charge on this side?
-1.
4 plus 5 minus 1. So you have minus 5 plus minus 7.
6x. 8. 6. 6. 6x plus. 3h. Plus NO3 minus.
So you have 6 positive charge, you have 3 negative charge. So overall is 3 positive charge. 2 plus 3, 5. 8 H plus.
4h.
Sodium nitrite. Sodium nitrite, when you heat it in absence of air, you get sodium nitrate plus nitrogen plus sodium oxide.